In this video, we will talk about some important concepts in the domain of probability. So we will see things like random events, independent events, multiple trials, multiple configurations or paths, and repeatable or predictable patterns, and how these are all related with the concept of probability. To understand this, we will go through a simple and trivial example, which is the coin toss, because this is something we can easily understand and think about, and then we can transfer what we learned from this to more realistic situations that are relevant for our study. So, pause this video, go get a coin, toss it 10 times, and write down if you get heads or tails each time. I did this and I got this result. So I got heads the first time, and then heads the second time, tails the third time, and so on. This is an actual sequence of 10 coins flipped. Well, the same coin flipped 10 times, actually. Okay, so what about that? Let's do some counts so we can see and calculate what is expected and what is actual. In the first two tosses, I got 2 heads. So I'm going to write this down as 2 heads, 0 tails. If you look at my first 4, I got 1, 2, 3 heads and 1 tails. And so I can write that as 3 heads, 1 tails. If you look at the whole sequence, then in total, I got 7 heads and 3 tails. In past years, we would have everyone in class physically do this in the course of teaching statistics and write down what they got, and then we would count. Unfortunately, this is not possible now, but what we can do is we can have the computer do simulations for us that would be like a classroom. But you can still go through the experience with some friends or other students. So first, let's look at the possibilities. The first time we toss a coin, it can be either heads or tails, and it's equally likely to be either one of them. Then the second time, well, if you were heads the first time and you get heads the second time, then the pattern is heads, heads, and the count is twice heads, 0 tails. If you got heads the first time, the other possibility is you get tails the second time. So this would be your pattern, and this would be the count. If you got tails the first time, you could get heads the second time and get this pattern and this count, one of each. Or you could get tails the second time as well, so you'd end up with tails twice and no heads. So the only way to get heads twice is to get heads in the first and the second toss. But you can get heads and tails by either having heads first, tails second, or tails first, heads second. The probability of any pattern is how many ways you can get this pattern and how many different outcomes are possible. So how many ways divided over how many possibilities there are. Let's apply this to our actual situation. So these are the possibilities. We can have this or this or this or this. There are 4 different outcomes that are possible when you toss a coin just twice. And of these 4 outcomes, only one includes 2 heads, one includes 2 tails, and 2 have one of each. So how likely are you to get 2 heads? Well, there's only one way to do that. Out of 4 possible different outcomes, 1 divided by 4 is 0.25, which is 25%. Exactly the same is true for getting two tails. There's only one way to get two tails out of four possible things that can happen. That's 0.25 or 25%. But there are two ways to get one of each, and 2 divided by 4 is 0.5 or 50%. That's 1/2. So these are the expected probabilities of occurrence for three different kinds of counts, getting two heads or two tails or one of each. What if we toss a third time? Well, by the same kind of thinking, after having heads twice, we can either get heads or tails. After having heads, tails, we can get heads or tails. After having tails and heads, we can get heads or tails, and so on. Each time, we can again get one of the two options with equal probability. And these are the possible patterns. So 3 times heads, 2 times heads, 1 tails, and so on. And these are the counts. Obviously, the only way to get 3 heads in 3 tosses is if you get heads in the first and the second and the third toss, and so on. What about a fourth toss? Again, after each possibility of the third, we have 2 possibilities of equal probability in the fourth, and these are the possible patterns. These are all the possible resulting patterns. They're all equally likely because each one comes after a series of events that are equally likely. And these are the corresponding counts. And we're not going to go through all of them. Just to note that each outcome at each coin toss can lead to 2 options for the next one that are equally likely. So there are all these possible paths one can take. And every person who tosses a coin 4 times will necessarily take one of these paths. These are all the possible options. These are all the possible patterns of results one can get. And, well, how many are they? Well, there's 2 options. First, when you first toss the coin once, and then there's 2 options when you toss the second time. So the total after 2 tosses is 4 different things that can happen. But we've already seen that. Then you toss again with 2 options. So you double the number of possible outcomes. And then you toss again with 2 options. And again, you double the number of possible outcomes. So there's 16 different patterns that you can get. Let's generalize this a little bit. So at each trial, each time we toss a coin, we multiply by how many possibilities there are. In this case, there are 2. So 1 toss, there's 2 possibilities. We get heads or tails. 2 tosses, 2 times 2 is 4 possibilities. 3 tosses is 8 possibilities. 4 tosses is 16 possibilities. So if you look at this, essentially we're multiplying 2 by itself as many times as we toss a coin. So 1 toss is 2 just multiplied by nothing, just 2. So once. 2 tosses is 2 multiplied by itself 2 times. 3 tosses is multiplying 2 by itself 3 times. 4 tosses multiplying 2 by itself 4 times. So this is 2 to the 4th power. And in general, if you have any number of tosses and n tosses, there are 2 to the nth power possibilities. 2 to the nth different possible outcomes. Let's see how many different kinds of outcomes we can get. So there is only one way to get 4 heads in 4 coin tosses. That's because the only way to get 4 heads is to get head in the 4th and the 2nd and the 3rd and the 4th. How many ways are there to get 3 heads and 1 tails? Well, there is 4 possible places where tails can come up. So they can come up in the first time or the second time or the third time, or the fourth time. These are the only ways you can get 3 heads. So there's 4 of those because there are 4 positions the only tails can be in. And there are 6 ways you can get 2 of each. We're not going to go through these one by one. So the probabilities for getting these different outcomes are, according to the rule we showed before, dividing by 16, because there are 16 different patterns. There is only one way to get 4 heads. So 1 out of 16 is 6.25%. That's how likely you are to get 4 heads in a row. The probability of getting 3 heads and 1 tails in 4 coin tosses, there are 4 ways to get that, divided by 16 total possibilities. So that's 25%. The probability of getting 2 of each is 6 divided by 16. That's 37.5%. And likewise, for one's heads is the same as 3 tails, so it's the same as 3 heads in terms of probability. And no heads is the same as all tails, which from a probabilistic point of view is the same as 4 heads, so is 1 over 16. You can go back and see the actual patterns and count them if you like. So these are the expected probabilities. And a very important property of these is because they are all the possibilities. We've exhausted all the possibilities of what can happen. There's nothing else that's possible. If you toss a coin 4 times, you can get either 4 heads or 3 heads or 2 or 1 or none. That's it. So there's 16 things that can happen. And these are all of them. So if you add 1 plus 4 plus 6 plus 4 plus 1, you get 16. And if you add the corresponding probabilities, they must add to 100%. So these are the probabilities, they add up to 1. So the total probability is 1. It has to be 1. What does it mean, 1? 1, probability of 1 means certain. What are we certain about? We are certain that something will happen. I know that doesn't sound like much, but this is what it means. We are certain that one of these patterns will occur. So the sum of the probabilities of all possible events adds up to 1 because we are 100% sure that one of these will happen. Of course, we don't know which one, but we know how likely each one of them is. Now, if you recall, we actually tossed the coin 10 times. What about the possible outcomes from 10 tosses? Don't panic, we're not going to start counting, but we can still calculate some things easily. So how many different possible outcomes are there? Well, it's 2 multiplied by itself 10 times, and if you bother to do that, you'll see that it is just over 1,000. It's 1,024 different possible outcomes. Okay, so how likely is it to get 10 heads in 10 coin tosses? Well, there's obviously only one way to get that. You have to get heads every time for this to happen. So there's one way for this to happen divided by 1,024 possible patterns. And this number is about 1 per 1,000, just a little bit less than 1 per 1,000, or 0.1%. This looks like a very small number, and indeed you would not expect to get 10 heads in a row. You would probably be very surprised if this happened. And you should be. However, if we ask a few thousand people and they all agree to toss a coin 10 times each, what would you expect? Well, if nobody got 10 heads in a row, you should be surprised. Of course, the person or persons who do get 10 hits in a row will be very surprised indeed. But if they don't occur, then you, knowing about the thousands of people, you should be surprised instead. So this means that an event that in itself is unlikely, less than 1 per 1,000 to happen, becomes expected if you try enough times, if you have enough people tossing coins. Okay, what have we heard so far? What are the important lessons from here? So one important thing to always keep in mind is to think of probability as frequency, as how often something happens, how often we can expect something to happen. So probability is also a kind of expectation. Something that's high probability is expected, something that's low probability is unexpected or surprising. The second important thing to remember is that the total probability, when we have exhausted all the possibilities of outcomes, has to be 100%. This means something will happen. And the probability of an outcome depends on the trials. It depends on how many times we try, how many people try it, or in how many different ways it can occur. Number of tries or number of different ways. And so low probability events will happen eventually if you try enough times or if enough people try. A random event is an unpredictable event. Indeed, that's what random means. It means you cannot predict what will happen. However, if you have lots of independent random events, then you can predict what will happen collectively, even though you cannot predict what will happen with each one of them. So these are the most important lessons that you should keep in mind as we go on to discuss more about probability later in this course.